So given this function f of x, where is f not differentiable? If I read the graph from left to right, the first problem I come to is that x equals -1. So at x equals -1, there's a problem. F is not defined at x equals -1. X equals -1 is not in the domain of f. So if you told me that f was not differentiable there, yeah, that kind of makes sense. But really, a function does not have a derivative at any place that is not in the domain of the original function. So this one's not so much not differentiable as at x equals -1, as it is an example of a function not having a derivative, not even having a discussion about the derivative at any place where the original function was not defined. So I wouldn't feel obligated to explain why there's no derivative at x equals -1. But if on the AP test you said f was not differentiable at x equals -1 because f is not continuous there, nobody would argue with you. So I'm going to keep reading from left to right. The next problem I come to is at x equals 0. F is not differentiable at x equals 0 because f is not continuous at x equals 0. X equals 0 is in the domain. I can figure out what f of 0 is, but since the function f is not continuous there, I have to talk about whether it's differentiable, and it does not happen to be because f is not continuous. I'll show you how I would write it up. All right, so for a very thorough answer, you would say f of x is not differentiable at x equals 0 because f of x is not continuous at x equals 0, and then you would give the reason that you know f is not continuous. I would say the limit as x goes to 0 of f of x is not equal to f of 0. So that's a complete answer for why f is not differentiable at x equals 0. We would, so I'm reading from left to right. Our next problem is at x equals 1. At x equals 1, I have a corner. The slope to the right of x equals 1, well, the function's going uphill, so the slope must be positive. I could figure it out, except I didn't label the exact values on the graph. And to the right of x equals 1, the slope is negative. So the slope from the left does not equal the slope from the right. Here's what I would write up. So if we want to really justify this, we're going to have to give a reason that we know the two slopes are not equal. I have not given you enough information to compute the slope exactly, so I might write something like this. F of x is not differentiable at x equals 1 because the limit as x approaches 1 from the left of f of x minus f of 1 over x minus 1 is greater than 0. I can tell the function is increasing, going uphill. And limit as x approaches 1 from the right of f of x minus f of 1 over x minus 1 is less than 0. So the limit as x approaches 1 from the left of f of x minus f of 1 over x minus 1 is not equal to the limit as x approaches, I wrote the letter x twice there, 1 from the right of f of x minus f of 1 over x minus 1. My next problem, as I'm reading from left to right, is at x equals 2. F is not differentiable at x equals 2 because f is not continuous. And so for complete justification, I would say f of x is not differentiable at x equals 2 because f of x is not continuous at x equals 2. And now I want to explain why I know f is not continuous. I would say the limit as x approaches 2, that's an x approaches 2 from the left of f of x, is not equal to the limit as x approaches 2 from the right of f of x. If here, instead of what I just hand wrote out, you wrote the limit as x approaches 2 is not equal to f of 2, is technically true, and I appreciate that that's the definition for continuity, but it sort of misses the point. Why is the function value not equal to the limit? Because that limit doesn't exist. One last place you might investigate is at x equals 3. But I would argue that f is differentiable at x equals 3, unless they're really trying to trick us with this graph. because as I approach x equals 3 from the left, kind of seems I have a horizontal piece of my piecewise function, so the slope seems to be 0. As I approach from the right, that curve is flattened out, so it seems like where they connect feels smooth. Maybe they made that dot so big that they're trying to hide something, but they're not going to try to trick you like that on the AP test. So my sort of the gut check that I do is, does it look smooth? I don't see a corner, I don't see a cusp, I don't see anything pointy. It's definitely not the case that there's a vertical tangent, because the tangent seems, in fact, horizontal. And the function f is continuous. So I would claim that this function is differentiable, so I'm not going to give a reason for why it's not. All right, so this second example, I have a piecewise function. I've been asked, at x equals 3, is f continuous? Is it differentiable? Well, first I'm going to try to figure out if f is continuous at x equals 3. If I find out it's not continuous, then I know for sure it's not differentiable. So how can I decide if f is continuous at x equals 3? Well, I need the limit from the left to equal the limit from the right, and for that limit to equal the function value. So I'm going to start by finding and labeling. Some of you, I'm checking your free response notebooks, and you have done all the math to compute the limit from the left and the limit from the right. But if you don't label them as the limit from the left and the limit from the right, then you don't get the credit for later referring to the limit from the left and the limit from the right. We have to know that you know which was which, and that's what you were meaning to find. So this is going to be the limit as x approaches 3 from the left. From the left, I'm coming along x values that are less than 3, so I'm going to use this top rule, and that's going to be 3 squared, which is 9. And from the right, the limit as x approaches 3 from the right, it's going to be 6x minus 9 with the x replaced by 3. That's 6 times 3 minus 9. So 6 times 3, 18 minus 9 is 9. And this also happens to equal f of 3 because of my or equal to symbol down there. So what have I decided? I can conclude f of x is continuous at x equals 3 because the limit exists, because the limit from the left equals the limit from the right. The limit as x approaches 3 of f of x equals 9, which equals f of 3. So that's good, because if this function weren't continuous, I wouldn't be able to even have a discussion about whether it's differentiable. So how can we decide if this function is differentiable? So for a function to be differentiable, we need the slope from the left, the derivative from the left, to equal the derivative from the right. So the slope from the left, again, I'm going to be using this rule if I'm talking about approaching x equals 3 from the left. So I'm going to be finding the limit as x approaches 3 of, this is going to be f of x minus f of 3. So this is going to be x squared minus 9 over x minus 3. That's f of x minus f of a over x minus a. Oh, well this, I recognize that pattern. That's going to be the same as the limit as x approaches 3 of x plus 3 times x minus 3 over x minus 3. I'm going to cancel out. This is me simplifying. In my head, I already tried substitution. I tried replacing x with 3. And I'm going to have 0 over 0. That's an indeterminate form. I have to try something, some algebra, to try to rewrite my limit so that I can later use substitution. But once my x minus 3 factors in the numerator and denominator cancel, I can use substitution. That's going to be the limit as x approaches 3 of x plus 3, which is just 3 plus 3, which is 6. So the question is, if that's the slope from the left, what's the slope from the right? Can I figure it out? Sorry about the red. So I could go through that same process on the right. Feel free to use the definition, the alternate form of the derivative to find that. But I love shortcuts, so I'm going to notice that as I approach 3 from the right, that function is linear. 6x minus 9, it has degree 1. The exponent on x is 1. It already looks like it's written in mx plus b form. This is linear, and the slope is 6. If I went through the alternate form of the derivative work and computed it out, I would get 6. But feel free to use this shortcut. Anytime you see a line, you know how to find the slope, so you know how to find the derivative. So I would say the limit as x approaches 3 from the right, of f of x minus f of 3 over x minus 3, I already know is 6. So is f differentiable? Yes. F is differentiable. Yeah, I switched to typing so it's easier to read. Yes, f of x is differentiable at x equals 3 because the limit as x approaches 3 from the left of f of x minus f of 3 over x minus 3 equals the limit as x approaches 3 from the right of f of x minus f of 3 over x minus 3. That's that formal definition for differentiability that you wrote into your notes and that you wrote onto your important facts paper. So there's a textbook assignment for you, and we'll see you in class tomorrow.